Hey everyone, so this is going to be the last example and last video for the notes on optimization word problems. So let's just jump right in. The AAA toy manufacturing company with 2 production plants produces only one toy, a small plastic doll. It costs $4 to produce one doll at the plant in Winkler and $3 to produce one doll at the plant in Altona. The company has 900 person hours per week of labor time available and has set a weekly production cost of $1,800. It takes 1 hour to produce one doll in Winkler and 3 hours to produce one doll in Altona. Find the largest number of dolls that can be produced in 1 week. Alright, so first off, what do we want to know? Well, we want to know the largest number of dolls that can be produced in 1 week. So let X be the number of dolls in Winkler, and Y be the number of dolls in Altona. Oops. Alright, and again, as always, negative number of dolls made doesn't make any sense, so we're going to have X is greater than or equal to 0 and Y is greater than or equal to 0 as 2 of our constraints. So, part B, write the constraints for the problem. So there's 2 different constraints that we're going to look at. The first is the 900 person hours per week. Alright, so if this is hours, we're just going to look through the problem and see where else it talks about hours. So we see it takes 1 hour to produce a doll in Winkler and 3 hours to produce a doll in Altona. So 1 hour in Winkler, so 1 times X, or we can just write this as X, plus 3 hours in Altona. Number of dolls in Altona was Y, so 3Y is less than or equal to 900. So that's the number we can't go over. The other thing I see is the $1,800. Now this time the money is not what we're actually trying to maximize. We're trying to maximize the number of dolls that can be made. The money is just a constraint here because it's just the money to produce the dolls. Alright, so it costs $4 to produce one doll at the plant in Winkler and $3 to produce one doll at the plant in Altona. So it's $4 in Winkler, so 4x plus 3 in Altona, so 3y is less than or equal to the $1,800 that's the production cost for the week. Alright, part C, write the profit equation. Now, the profit equation is kind of weird because it's not talking about actual profit because we don't know how much money these dolls actually make. All we're trying to do is find the largest number of dolls. Right? So if we just want to know how many dolls can we make, then the total number of dolls that we're making each week would just be the number of dolls in Winkler, which is X, so P equals X plus the number of dolls in Altona, which would be Y. So it's a really simple profit equation this time, nothing too fancy. Alright, let's get to graphing these. So our first one was X plus 3Y less than or equal to 900. We can subtract X from both sides, get 3Y is less than or equal to negative X plus 900. Divide both sides by 3. We get Y is less than or equal to negative 1/3 X plus 300. All right. So obviously I'm not going to go up 300 notches. So I'm just going to say these are 100, 200, 300, 400, 500, 600, and so on. And same thing on the x-axis. 100, 200, 300, 400, 500, 600, and so on. Alright, so for this first one, we go up to 300, then down 1 over 3, down 1 over 3, over and over. Draw the line through it. Put our arrows. We're good to go for that one. Which, by the way, one thing that I did not show, but don't forget, the axis are also two of our constraints. So I'm just going to go ahead and bolden those up just so we remember that those are constraints. All right, next up, we had the 4x plus 3y is less than or equal to 1800. So if we subtract 4x from both sides, we get 3y is less than or equal to negative 4x plus 1800. Divide both sides by 3, and we get y is less than or equal to negative 4/3 x plus 600. Alright, so it means it's up here at 600, and then we go down 4 over 3. And then we can't do it again, so we're just going to go ahead and draw the line through those two. And that's all of them graphed. So we're ready to just shade in our region. So again, all of them are less than or equal to. So that means the region we're shading is the corner. Alright. Now, as always, I'm just going to go ahead and outline this just so it's a little bit brighter and we can see where our corner points are. Alright, so find the optimal solution. So again, we're going to be doing this by corner points. So if we want to do this by corner points, our first thing we have to do is find those corner points. So we got 0, 0, 0, 300, 300, comma 200, and then, that one's not a nice point. Alright, so while it looks like it's around halfway between 400 and 500, would you be able to tell the difference on a graph between 450 and 451? Probably not, right? It'd be extremely close. So we're just going to check. Easiest way to check is that point is special on the red line. That point is the red line's x-intercept. Right? So over here, we have the red line. If we want to find its x-intercept, that way we can find what that point is, all we have to do is set y to 0. And now we solve. So subtract 600 from both sides. We can multiply both sides by 3 just to get rid of the fraction. And then divide both sides by negative 4. And if we do that, we're going to get 450 is our x, so 450, 0 is that point. Alright, again, if it looks like it's on a nice point, then for our class it probably is. But if it obviously looks like it's in between, then you're just going to need to do this. You're going to need to find another way to check what that point actually is. Right? Usually it's either going to be an intercept or it's going to be where two of the lines cross. So either way, you'll be able to figure out what that point is by just doing a little calculation. Alrighty. So now that we have those, we're going to need to make our chart, and we're going to need our profit equation, which remember, it was just x plus y. Nice and easy. So our point, we have 0, 0, 0, 300, 300, 200, and 450, 0. X plus y is what we're actually doing, and that's going to give us our P. All right. And by the way, just in case I didn't say this in the last video, whenever I put PT right here, it just means point. That's it. I'm just abbreviating point. All right. So if we go ahead and start plugging these in, we're going to have 0 plus 0 is 0. 0 plus 300 is 300. 300 plus 200 is 500. And 450 plus 0 is 450. So this one gave us the biggest number. Now, don't forget, we do want to write our answer in some actual words, because it was a word problem, right? So our answer should also be words. So our optimal solution was we were looking for largest number of dolls. Okay. So the largest number of dolls is 500 by making 300. Remember, 300 was our x. X was Winkler, so in Winkler. And 200, which was our y. Y was Altona, so in Altona. And then we're done. All right. And that concludes the notes for the optimization word problems. At least doing them by graphing. All right. Bye, guys.